Hello everyone, these are some extra examples on finding volume. In this case, we're going to find the volume of the combined prism. Notice that this diagram shows one box that's on the floor and then there's another box on top. This sort of looks like when we're stacking presents underneath a Christmas tree. We have a bigger present at the bottom and a smaller boxed present on top of that one, okay? So this is a combined prism. We don't have a formula to find the volume of the whole thing as a whole. We could find individual volumes and then add them together. So I'm going to find the volume of the bottom box. The bottom box is a rectangular prism, and you should know that the volume for a prism is B times H. That means the area of the base times the height. So looking at our diagram, let's look for volume. The area of the base, since it's a rectangle, I know this will be length times width, and the height would be the height of the box. So let's look. The length of this box down here, I can take the length as 7 and the width as 10, or the length as 10 and the width as 7. It doesn't matter. So 7 and 10 are the two numbers that I'm going to use to find the area of the bottom box, okay? So that would be 7 times 10. And the height of this box is, how tall is this box right here? It's 4 meters times 4. So 70 times 4 is equal to 280 cubed meters, and that would be the volume of the box. Very simple. Now let's do the volume of the box that's on top. For the volume of the box that's on top, again, we need the area of the base. Now the base of this box is this length here times this width right here. Do I know those two measures? Yes, I do. This length here, remember, I'm going to use the base as the part of the box that's sitting on that base. So this length, if you notice, down here it's 7. Okay? Now this is a parallelogram, so this will be 7 also. Okay? And if this is 7, then this should be 7 also. They're all parallelograms, opposite sides are congruent. So this is a 7 right here. And for this width, I know that this width up here is 2. So if that's 2, this is 2 right here. And if this is 2, this must be 2. So I can find the area of the base as 7 times 2 times the height. What is the height of this box? How tall is it? Well, it's this height. And this height I know to be 5. If this height here is 5, then this is 5, and if that's 5, then this is also 5, and you get the idea. The height is 5. So in total, the volume of the box on top is 14 times 5, which is 70 cubic meters. So now to find the total volume is 280 plus 70, and that gives you 350 cubic meters, and that's the answer. Let's do one more example. Find the volume of the solid. Here we have a cylinder, and we also have a smaller cylinder that's been cut out of the big cylinder. So we can think of this as, let's say, a car wheel. A car wheel has a certain diameter and it has a hole, right, that's been removed from that cylinder. We can also think about a donut. A donut has a hole that's cut out from its center, okay? So already I know that I need to find the volume of the whole cylinder, the whole thing, the whole solid. And then I'm going to find the volume of the smaller cylinder that's been cut out, and I'm going to subtract it because it's been cut out, so it's been removed. And the way we remove in math is by subtracting. So let's start by writing the formula for the volume of a cylinder, which is the area of the base times the height. Now remember that the base in a cylinder is a circle, so this letter B will be substituted by the formula for the area of a circle times h, which is the height of the cylinder. So let's go ahead and do the volume for the big cylinder, for cylinder 1, the big one. Okay, and from the diagram I can see that the radius of the big cylinder, which is, let me change this color, which is this big circle out here, this big cylinder, the radius is showing you that from the center to the outer edge, the radius is 8. So that's the radius I'm going to use, 8 squared, times the height, which is 10, times 10. And volume 1 will equal 640 pi. That's the volume of the big cylinder, cubic feet. Okay, now let's do the volume for the small cylinder. So the volume again, volume 2, we said would be the area of the base times the height. Volume 2 is equal the area of the base. Again, this smaller cylinder, the base is a circle, so I have to use the formula for the area of a circle. So here it is, pi r squared times the height of this cylinder, which is the same height as the outer cylinder. It's 10. They stand at the same height, times h. So volume of the second cylinder would be pi times radius square. Now this radius, we have to consider the radius of the small circle here, and it's showing you that from the center to the outer edge right here, there is a radius of 3 feet. So 3 squared times the height, which is 10. Volume 2 will give you 90 pi. When you multiply 3 squared, which is 9, times 10, you get 90 pi. Okay, now I have the two volumes. Remember we said that this small yellow volume we are going to remove from inside of this cylinder. So to remove that mathematically, I need to take volume 1 and subtract volume 2 from it. That means 640 pi minus 90 pi. That gives you a total of 550 pi cubic feet, and with your calculator you can approximate this to 1,728 cubic feet. So there are two additional examples. I hope you understood. If not, go back, watch again. Try them on your own and check your answers. I'll see you in the next video.